Hello everyone, my name is Vikas Oja. Welcome to my channel Coding Together. Today we will see a lead code problem number 50, that is power x of power xn. So it's a problem statement for this problem is very simple and clear, that we have to only find the power x raised to the power n. So we are given with a decimal value x and we have to calculate the x raised to power the n given as the another value. So if for this example, if we perform x raised to power n, that is 1024. So how can we do this question without using the inbuilt method? So let's see. So here we will use a divide and conquer method. So let's take an example where we want to calculate the power of 2 raised to power 10. So is there any way that we can divide this task into some smaller tasks? Yes, if we can see that 2 to power 10 can be written as 2 to power 5 into 2 to power 5. So that will give a result as 2 to power 10. Again, we will see that 2 to power 5 can be written as 2 to power 2 into 2 to power 2 into 2. So we are seeing a pattern here. What pattern is that every time we can divide the larger task into smaller task by dividing the value of n. So if we divide the value 10 by 2, we will get 5 and we will perform 2 to power 5, and whatever the result we will get for 2 to power 5 will multiply with itself to get the final value for 2 to power 10. Then now again we can see whether 2 to power 5 can be again broken down. Yes, 2 to power 5 can be broken down 2 to power 2 and into 2 to power 2. The only point is that 5 is an odd number, so we have to multiply with an extra 2. Now we can see that whether we can divide the 2 to power 2. Yes, 2 to power 2 can again be divided into 2 to power 1 into 2 to power 1. Again we will see, so we are seeing a pattern here. So every time we are dividing by 2 the number n. So we'll have to choose our base case. So as we know, as soon as we reach 0 while dividing the number 10 by 5 to 2 to 1 and to 0, we have to return 1 as our base case. So let's see also if the x is equal to 0, then we can return 0 at base case. But if we have seen here as our constraints that x can be minus 100, greater than minus 100 to smaller than 100 value. So it can be 0. If it is 0, then we'll return 0 as it is. So these are our two base cases. So let's see a sequence diagram. We'll start with power 2 to 10. So as we saw that we can break it down, this power function, into power of 2 comma 5, and the result of this power 2 comma 5 we can multiply with itself to get to for power 2 comma 10. Again we will see that whether we will divide 5 by 2. So here we have divided 10 by 2 to get 5. Now again we have dividing 5 by 2, that is the integer value 2. Again we will divide 2 by 2, that will give us 1. Again we will divide 1 by 2, that will give us 0, reaching to our base case. So as soon as we reach our base case, we will return 1. And now we will check the value n. So n is odd. So as stated before, that if the value is odd, we'll multiply with an extra x with whatever the result we are getting from the downstream. So 2 into 1. So 1 is what we are getting from the downstream. We'll multiply with an extra x and we'll return upwards. So here we check that the n is even, so we don't have to multiply with an extra x. We'll just multiply the number what we are getting from the downstream with itself. So here you can see the 2.0 that we are getting from downstream, it's getting multiplied with by itself. Now we will return upwards. We'll see the number is odd. The number we are getting from the downstream is 2 into 2, that is 4. We'll multiply with itself and with an extra 2, and we'll revert upwards. That will be 32. And we have seen that the n is even, so we'll just multiply with itself, returning 1024. So another case can be the n can be negative. Suppose that n is negative, what we have to do is we have to just take the modulus first and perform the same operation, and after that we will just invert the result, that is 1024. Why? Because if we say 2 to power minus 10, it means it is same as 1 upon 2 to power 10. So let's see the code part of it. So here as I stated that if m value is less than 0, we'll just inverse whatever the value we are given, and we'll pass the absolute value of m inside the function. Else we'll perform the regular operation with a positive value. Here we'll initialize a temporary variable equivalent to x, and if m is equal to 0, this will be our base case, we'll return 1. And if we'll store the temporary variable performing while dividing the m by 2, as we see at every stage we'll store the temporary variable. Now after performing the iteration, we'll see whether the m is even or odd. If it's even, we'll just multiply the result, the temporary variable, with itself and return upwards, or we will also multiply with an extra x. So let's run this code. So yes, the test cases are passing. So hope you like the video. If you like the video, please do subscribe and comment. It will give me motivation to present you more videos in the future. Thank you.